If we could visualize what the computer does electronically, we would see that it discovers omissions and misinformation introduced by human error. These errors are printed out. The necessary corrections are made either by changing the information on punch cards or by tracing the correct lines and loops with the digitizer. The corrected map information is fed onto the tapes. This, then, is the storage system of the Canada Land Inventory. For the first time, we can use all of the information we have gathered over the years. Special maps can be made on request. Suppose an administrator wants to know how many viable farms his region can support. What areas should get assistance for agricultural development. He fills out a request using plain language. This is a normal request. The computer could handle many other factors as well. Farmland could be measured in relation to good roads, or freight rates, or profits over cost per acre. The request is translated into code, and the code into punch cards. A similar request has been made before. The computer refers us to an existing file of statistics and maps. As our administrator looks at the file, he formulates another, more complex question. These are the viable farms. But what about people who live in other areas? Are there possibilities for recreation, wildlife, or forestry? Where should the government invest in development? What is the best land use in each area? What are the human resources, education, income? The computer indicates the tapes on which all this information is stored. Now it will compare and analyze all the factors at a speed that human hands could never match. The administrator no longer has to make decisions by guesswork. He has access to all the available information concerning land. He can get it in map form, on any scale, instantly. computer can replot these maps at any scale with the accuracy of oceanographic charts. But even when a map has been prepared, the administrator can study it and alter his request to get the combination of information best suited to his needs. The information he has received suggests where the problem lies. One of the 3 counties has good land, but its farmers have very low incomes. Why? He needs more detail as soon as possible. He starts to ask what information we have about the area.
I'd like to take another look at those 3 counties in Ontario, Omar, Otter, and Birch County.
Okay.
Can you give me the enumeration areas for Birch County?
Yes?
That's too small. Can you blow it up a bit?
Yes.
I'd like, we're going to need some information. Can you set up the enumeration area data block?
Okay.
And how about the number of farms?
Okay.
What's this W36 here?
Well, there was only 1 farm in 37, so it was included in 36 for confidentiality.
Could you give me average gross sales on the
I think that's on here.
column 2? It's not very good, is it?
Oh, pretty low.
Low-income farms on good land? Are there too many farms? Are they too small to be viable?
What about the capability? How many farms can could the area support?
What input assumption?
Oh, assumption P.
Okay.
That's less than half of the present number.
Yes.
Let's have a look at the education, average level of education, and keep the figures in column 1. Would you?
Okay.
He calls on census data. Now he knows the size of the problem. Can the government develop other resources in the area?
Could you give me the forest capability?
For all 3 counties?
Yes, for all 3 counties.
Okay.
The recreation? Put them together.
Okay.
Yes, that looks quite promising.
The problem is not solved yet. Much work needs to be done. But for the first time, much of the information he needs is accessible and useful. The data is in the hands of the decision makers.